We have prepared 2 hands-on sessions for this module. You can click the button at the bottom, Open in Colab, to open up the Calaboratory, Google Calaboratory for this module. So this runs on Google Cloud Computing Platform, and it's using the resources to run your Jupyter Notebook. So this is free for anyone with Google account. If you are at Texas A&M, you should be able to log in directly with your university account. If you want to have some other features not provided by the free account, you can pay a fee and use some advanced features that we'll not cover in detail today. But for this module, this free version should be sufficient. To get started, the easiest way to run all the cells here is to click the runtime menu and then click Run All and then click Run Anyway. So all the executable cells will be running, and you can see the output will be printed out on the screen. So there are 2 types of cells. The first type here is called a text cell. As you can see at the top, you have code and a text. Actually, each cell for the text cell, you can directly edit. This is using so-called markdown format, and you can look into the details and do a quick search online and figure out how to write those kind of like markdown format documentations. Google will render that into HTML, and you can export that into HTML directly or print that into PDF. The embedded code here, it's in the so-called code cell. The code cell is executable. You can run it using the button to the left here, or you can click the runtime and run following the instructions on the menu and run each cell or the cell after. In this Jupyter Notebook, we'll show how to build a linear regression model using Keras. So we start by creating a dataset. As you can see, the dataset here is simply an X array, input array from -1 to 5. And then we have a Y constructed by giving the formula 3x plus 2 plus a random number. This random number is generated for every data point. So you have the variation as I show here in this plot. So the line here is a 3x plus 2 line. And all the data points spreading around using the scatter plotting function, and just pulling out the XY position of all the data points I have. For the scikit-learn package, which will be covered in another module, the linear regression model could be easily done by simply calling the linear regression function. And here I just show this example as a reference. And you can check with the module on the machine learning. And we'll talk about scikit-learn and other tools to do the very simple linear regression. But for this module, we are looking to the linear regression with Keras. Keras will be using so-called dense layer, and we have only 1 input and 1 output, because for every data point, that's your training data, with 1 input, which is X, and 1 output, which is Y. Using X and Y, you can train the model to do the mapping from X and Y. So the optimizer we're using is a stochastic gradient descent, and then the loss function we use is simply mean squared error. This is the one usually people use for the linear regression models using deep neural network. Then you do the fitting with 500 epochs. So you take the data and train that through your iterations. You don't need so many epochs. I just use it here just to demonstrate. Then you can also turn the variables into 1 to see the detailed output during the training state. So then you do the fitting. After the training is done, you can call the predict function do the fitting. And then you can plot out the fitted value against the input value. And you can compare that with the original dataset, X and Y. And the Y fit here is a predicted value. And you can see we are getting function, linear function, Y equals to 3.04, X plus 1.94, etc. So that's kind of close to 3x plus 2 that we used to create this dataset. And you can try to change the number of epochs and other things to see how much difference this will make to get your linear model. You can also compare this to the scikit-learn linear regression model to see the difference here. And you can see it's not the same, but they're close to each other. So for Keras, it's mostly about layers. And this one is trying to show you a very simple approximation function that we are trying to build with multiple dense layers. And the input dense layer here, we have 64 units, means we have 64 neurons created. With the input dimension 20, we are trying to create an extra hidden layer of 64 neurons. And then finally, we have 10 neurons as the final output. We're using activation function softmax to help us to give us a mapping to the probability that softmax is mapping to, which is able to map all your input into the range of 0 to 1. Then we have the categorical cross entropy, which we use to do some estimation, which doesn't really give us any useful information here, but it's just trying to show you how all these procedures working and all these functions are working. And we'll look into a more detailed example in the next hands-on session.